So this is Statistical Rethinking, second edition, chapter 15, and we're in the tail end of the hard questions, 15H5. So we'll go through the question here, but if you're going to use this code, make sure you come up here to runtime, change runtime type, and make sure that you're in R. Also, because we're using Stan in the Rethinking package, make sure you run these first several blocks of code up at the head here. Okay. All right, so in the last question, 15H4, we played with the primates 301 data, and we fit a log normal distribution to brain size, where we were predicting brain size as a function of body mass. Okay, and in that example, we wanted to basically try to make up some measurement error and then account for that measurement error. And so you can go watch that video for that. Okay. In this question, we are doing something kind of similar. But now we are going to try to account for missing values in the data, and specifically in the outcome, brain size. So the question is actually kind of long in terms of text here, but the first thing that it has us do is just kind of count the number of NA values in our data set here, just to show you kind of how spotty this data set is. And then we are taking complete cases of both M and B, and what we come out with is a data frame that has 238 observations, but 56 of them are missing. Okay, but didn't I just say that we were taking the complete cases? So what's going on is that M and B both have missing values, and so I take their complete cases, and of them there's 56 that don't, where there's some for M and not for B, basically is what's happening. Okay, so we're going to try to determine the pattern of this missingness, and then use imputation in order to, try to fix the problem that's occurring because of the missingness. Okay, and it gives us a little bit of code here to help our code run a little bit more smoothly. However, I think I've discovered that maybe Stan has updated and Rethinking has not. The Stan package has updated and Rethinking has not, to where some of these little auxiliary arguments in your model don't make a difference. They don't, they're not passed to Stan. So, but we'll do it anyway. Okay, so the first thing we want to do is to try to determine the pattern, not the pattern, is to determine the pattern of the missing values here. So I'm just plotting the missing values across body mass here, and we see that they're all clustered, that the missing values up here on the top are all clustered, except for this guy right here, but mostly clustered at low body masses. Okay, so what we know is that these are not missing completely at random, right? Because if that was the case, then they would just kind of be smeared across the horizon here. So, but that's not what's happening. So it's some other, more exotic form of missingness. And so that leaves either missing at random or missing not at random. Okay, and so we'll kind of look at these. So we're supposed to draw some DAGs for these. So, so if it's missing at random, then we get this motif right here. These were taken from the dog eating homework example in the book. But where body mass is affecting the variable that we're interested in, but we don't get to see the variable we're interested in. We get, because some of it is missing, and instead what we get to see is B star down here. And B star is a function of what is true and whatever's causing some of the values to go missing. Okay, it could also be the second type of missing at random, okay, which maybe looks like this, right? So now, well, we've talked about these, so maybe I won't belabor the point. And missing not at random, and where the missingness mechanism is directly tied to the value of the of the variable of interest here. So what type do we have? Well, I don't know, but it does not. It certainly does not seem that it's missing completely at random. It's one of these other exotic forms, and that's about as far as I can tell. Um, and I think that the reason that that's as far as I can tell is I think that you actually have to have some kind of subject matter expertise to begin to come up with, what could be causing the missingness here. And I don't think that we have enough subject matter expertise to determine that. Could be wrong. There may be statistical ways of figuring that out, but I'm not aware. Okay. So the first thing that we do is I'm just going to run the complete cases data or model from 15H4. So this is where we have all complete cases, right? So there is no missingness here, okay? And so, we're going to run that. And then for the imputation model, we need to impute values, and the values that we need to impute are in the outcome in B here. And so in order to impute values, we just, whatever variable has missing values, or set of variables that have missing values, we just need to set a prior. We need to say these are what the values are likely to be, and the model runs, and given the actual values, it starts to refine that prior. Okay, so in this case, the thing that we're telling the model or the values we're telling the model to expect from B is just the likelihood. Okay, so the two models actually in this case do not change. Now it would be different if, say, there were missing values of M, in which case we would need to set a prior over M, but here we don't need to really change anything. Okay, so we run the same model, and here is that little bit of code that I mentioned that the question gives us to help the model run better. But like I said, I don't think that it actually makes a difference now. Maybe the author of the Rethinking package and this book will update things, but yeah, but right now they seem a little bit out of sync. Okay, but anyway, so we run these, and we'll look at the Prissy outputs here, and we see that they're basically identical. Okay, so they have slightly different data, right? Because the first one that we ran had fewer observations than the second one, because it discarded any missing B values, but we come out with basically the same posterior here. So okay, I guess we'll call it good.